All right, we're going to talk about slope here. We're going to start talking about equations of lines in general. But the first thing we need to talk about is slope. And if you think about going up a hill, like how high or how steep that hill is, if you're going up, or how steep it's going down, there's this idea of it not even being sleek, like if you're walking on sidewalk, it's straight. But all of these are lines, and we can talk about the slope of the lines. First off, let me make sure we know that slope is represented by m in any equation of a line. So m equals the slope of a line. And we'll have different forms of lines. We'll talk about those in a little bit, but m represents the slope. Now, the slope is also considered the rate of change. So if I go from one number or one value to another consistently, what is that actual rate of change? All right. That rate of change, it also kind of measures the steepness of the line. All right. So if we're looking at the line, or we're talking about like walking up and down a hill, the steepness of that walk, if you will. All right. One way of looking at slope is by looking at the rise, like how quickly it goes up, compared to the run, or how far it goes. So as you go up and over, what is that rate of change? All right. That's how far you go up and then over. Sometimes you hear it like, how far does it go up compared to how far does it go over? Now, by up, I mean up or down, depending on what you're doing, right? Because you could be going up a hill or down a hill. And then by over, I mean left or right. All right, so we can be moving left or right, and how quickly we go up compared to that is a measure of our slope. So in this introduction in general, let's make sure we think about and consider that the rise goes up and down, right? And so that implies the y value, right? So that is the change in the y. The run, similarly, is the change in x. It goes left or right, and that's associated with the x variable. Okay. Now, if I wanted to represent or actually calculate the change in y, I would have to have two different y's. And if I had two y's, let's just say you had the second y where you ended up, you subtract that from the first y. So if I started here and here, this would be a point, this would be a point, right? This point right here would be an x, this would be an x, this would be a y, this would be a y. Now, since there are two different points, let's let one of them be 1. That's the first point, and let the other one be 2. So I have x1, x2, y1, y2. Those are two different locations. So I'm talking about the change in y. I'm looking at the change in this y value right here compared to this change in y value. And then similarly, same thing for the x. Whatever the second x is minus the first x. So given all of this, I can come up with a way to calculate slope. If I have 2 points, then m is equal to the ratio. It's the rise over the run. The rise is the change in y over the change in x. So it's y2 minus y1 over x2 minus x1. So I could calculate the slope between 2 points. So for example, I could just say, if I could somehow, some way find 2 points, any 2 points, let's say 1, 2, and then 3, 4. I could say that the slope is the change in y, so it's y2 minus y1 all over x2 minus x1. This is x2, y2, x1, y1. If I do that math, it is 4 minus 2 all over 3 minus 1. That's 2 over 2, or 1. My slope is 1. All right, that's an introduction. Oh, actually, you know what? Let me just say this last thing. If you're going left to right and it's going up, that is a positive slope. If it's going left to right and it's going down, that's a negative slope. If it's going straight across, there is no rise, and so this is no slope. I want you to pay attention to an extra special case like this. When it's a straight up and down line, that slope is not applicable. It is undefined. All right, we'll talk about that later.